When naming multivalent ionic compounds, remember ionic compounds are metals and non-metals, but in this case, multi means that there's multiple charges on the metal. So on our periodic table, in single valent, we've been looking at ones that only have one charge. If we look towards the middle of the periodic table, these are the metals that have more than one charge. So for example, if we look at iron, it can go in the form of +3 or +2. And what this is saying is that iron becomes more stable if it loses 2 or 3 electrons. And it's willing to do that in either case to try and make itself more stable. And so there's multiple elements that will become more stable by losing either 2 or 3 electrons, or in this case of palladium, 2 or 4 electrons. And so we need to decide which or indicate which ionic charge is being used by the element. What else is important to remember is that these are different. So if we look at iron 3+ and iron 2+, they're different compounds. One has one less electron than the next. And so we need to make sure that we're indicating that when we go to name them. If we look at this example, chromium and fluorine. So chromium right here can come in the 3+ or the 2+ charge. I'm going to go ahead and write this name down, chromium, but I'm going to have to state, am I dealing with chromium 2+ or am I dealing with chromium 3+? It's important that we know that when we're going to answer this question, and I'll tell you how to figure that out after. If we look at the anion or the negative ion, this is fluorine, and we would change this to fluoride. Now, the biggest difference between naming single valent and multivalent is indicating which charge we're dealing with. To do so, we are going to add brackets in front of the chromium name and use Roman numerals to tell which charge we are talking about. And the Roman numerals should be given to you. This is 1, 2, 3, 4, 5, 6, and we only have to do 2 or 3. So to indicate which chromium ion we're using, we are going to use the number of atoms to help us out. So in this case, there are 2 fluorine atoms, and fluorine always comes with a charge of -1. If we look, chromium, there's only 1 atom. These charges have to balance themselves out. In order for the chromium to balance out the -2 on this side, it would have to be the +2 ion. And so that tells us that we are in fact dealing with chromium 2, not chromium 3. And so we name it chromium 2 fluoride. If we look at another example, we could look at something like MnO. Mn is manganese. Manganese comes in +2, +3, +4. And so I'm going to put my brackets there and figure that out after. And then I'll name the anion, which is oxygen, and that's going to change to oxide. So we change the ending to IBE. Now to go and figure out which manganese it is that we're using, again, I'm going to use the ratio of atoms present. There's 1 oxygen atom and 1 manganese atom. Oxygen always comes in 2-. That would tell us that this has to be the 2+ ion. And so we would write that this is manganese 2 oxide.